Amod.
Hi.
You are our famous Simultaneous 5-axis product manager and a highly regarded worldwide expert for simultaneous 5-axis machining. You always tell us that we have one of the best simultaneous 5-axis solutions today. So can you give us more details?
Sure. Hi. Welcome to the summit. My name is Amod Onkar. I'm the product manager for 3-axis and 5-axis milling. And in this presentation, I would like to present to you the packaging of SolidCAM 5-axis and how it is sold and how it is packaged for consumption. The agenda for today's presentation is I'm going to introduce the modules of SolidCAM 5-axis, how it is packaged, and finally the summary. Let's go ahead and see what we are offering currently in SolidCAM. So we have the generic 5-axis, 4 and 5-axis milling. We also have the multi-axis machining. We have the multi-blade machining, and we have the port machining, which is the application-based solution. We have rotary machining, we have edge breaking, we have edge trimming, and finally automatic 3+2 roughing. So these are the 8 broad classification of packages that we have, and then there are sub-classifications also of the packages that are there inside SolidCAM 2022 and 2021. So what does the generic 4 and 5-axis milling have to offer? So it's a complete generic solution, which means it's completely controlled by the user. Every aspect of machining can be controlled by the user. You can machine any part the way you like. You have full user control with the tool axis. There are user-defined gown check strategies, smooth lead in and lead out. You can apply different types of leads in, lead out macros to the tool path. We support all standard tools, including the circle end mills, which are basically the barrel tools. And we have got several strategies and sub-strategies inside the generic 5-axis machining, like parallel cuts, parallel to curve, perpendicular to curve, morph between two boundaries, morph between two surface, etc. And user even like engraving and stuff like that inside the generic 4 and 5-axis machining. We get exceptional surface quality in this because we machine the NURBS surfaces as they are without creating any intermediate mesh or any other thing. We directly machine the surface. So we get exceptional surface quality. We can reproduce the surface as they are on the part. Part of the generic 4 and 5-axis machining is also a rotary 4-axis finishing. This is designed to machine parts on a 4-axis milling machine. It can be used to machine cylindrical parts like bottle molds, cores, electrodes, jewelry items, woodworking panels, etc. Tool paths are directly calculated on the part and not wrapped. It's very important because we do the slicing and we do the cutting directly on the part, and we don't take a planar tool path and then wrap it around the cylindrical space. Strategies that are available are along and across. You can also shift the tool axis by defining a value, and you can use the tip of the tool or the edge or the side of the tool to machine the part in rotary. Next is the swarf machining. We have a very robust engine for doing swarfing. Swarfing is basically using the flank of the tool to machine the surface. The surface can be a straight surface, it could be a curved surface. So swarfing can handle both straight as well as curved surfaces. Minimum inputs, all you need to define is the machining surfaces and the floor, the tool, and some other entry and exit parameters, and that's it that are needed to machine the swarf geometry. Clean results, because here we do not directly machine them on surface, but we create a mesh and we generate the tool paths on the mesh so that the results are very clean and extremely reliable. Tilt control is automatically applied. User doesn't have to break his head on the tilt control, because many a times when you are doing swarfing operations, one of the most critical thing here is the tilting, and this tilting is controlled automatically by SolidCAM. Almost every user who is into machining needs swarfing, because swarf can handle all the axes. You can have swarfing in 3 axis, you can have swarfing in 4 axis, and you can also do swarfing in 5 axis. So any user who is into machining will, in one or other part, will need the swarf operation. And some of the applications are impellers, frame components, and production parts, including blisks also can be swarfed around their blades. Part of generic 4 and 5 axis, we also have a 3 to 5 axis conversion. This is a very useful tool to convert HSM, 3D HSM and Turbo HSM toolpaths to simultaneous 5 axis. These are generally needed when you want to machine really deep areas where you actually generate the toolpath without the holder, allow the toolpaths to be generated, and then apply the holder and convert it to 5 axis. So what the software basically does is it uses the holder, the tool, and checks for collision, and whenever there is a collision that is about to be detected, it tilts the tool to avoid the collision. Therefore, it converts a 3-axis toolpath, simple 3-axis toolpath, to a very complex 5-axis toolpath at just a click of a button. The process is completely automated with minimum user intervention. The user really doesn't have to put his brains into it on what it needs to be done. Everything is done automatically by SolidCAM. The next one is in the generic kitty is the multi-axis drilling, which basically is an operation that creates multi-axis drilling, taking the advantage of SolidCAM hold recognition process. So it uses the hold recognition process of SolidCAM and then applies, checks the vectors to create the multi-axis drilling toolpath. All advanced linking, tilting, and collision avoidance strategies that are there in simultaneous 5-axis and generic 5-axis are available to the user in multi-axis drilling. Drill depths are automatically determined by the software, and the user can edit and change even the drill depths as and when he needs to do. The next one in the package is contour 5-axis machining. This basically is a robust engine for machining only curves. You don't need to, the user doesn't need to define any kind of surfaces. Nothing of that is needed. He can just pick the edges and no surface input is needed. And all he needs to do is pick the edges and input some lines for creating the tool orientation, and the tool path is created. Now the application here could be for chamfering, for deburring, for trimming, different kinds of parts where this technology is very useful. And we support different cutters, whether they are ball nose, flatten mill, bull nose, chamfer tools, stepper tools, any kind of tools that are supported inside the contour 5-axis machining. We recently introduced, like a couple of years back, a technology called Geodesic Machining. Geodesic here means SolidCAM provides a new next generation evolution in field of the pattern generation. So pattern generation is taken care by this engine. And what happens in Geodesic is it uses a global field. That means if I define a step over distance as, let's say, 1 millimeter, irrespective of how the surface is and from which direction the machining is happening, that 1 millimeter is maintained looking normal to the surface at any given point of time. So it maintains a consistent distance between two cuts everywhere all along multiple surfaces. So that's the whole idea about geodesic machining. It works on mesh data as well as surface groups. So you can give the entire model, or you could give a portion of the model as a group of surfaces, and it will still machine it. We also introduced last year Auto 3+2 roughing, which is a very, very powerful module that uses the Turbo HSR and creates its own directions. The machining can here be done by automatic, semi-automatic, and manual method. In automatic, the software finds the directions automatically by itself, including the start direction. Whereas in semi-automatic, initial direction will have to be provided by the user. Once that is provided, the remaining directions are taken care automatically by SolidCAM. And in the manual input, the user specifies all the directions from which it needs to machine, and SolidCAM creates the toolpath automatically. One of the most critical applications for Auto 3+2 is right in front of you on the screen. It's a Pelton wheel. In a Pelton wheel, it's really very difficult to identify which is going to be your direction, how much material it needs to remove, and where it needs to remove, because there is absolutely no way a user can pinpoint at an area unless he looks at the simulation very carefully. This is completely taken out, and this particular part, for example, what you're seeing is about 500 millimeter in diameter, and this particular Auto 3+2 roughing took about less than 45 seconds to create in SolidCAM 2022. Remember that in SolidCAM 2022, Turbo HSR is about 3 to 4 times faster, so that effect is also seen here in Auto 3+2 roughing. And it detects the directions automatically, it detects the stock automatically, and it detects also the boundaries in which it needs to machine automatically. So most of the thing is done automatically by the Auto 3+2 roughing. Within the generic 4 and 5 axis milling, we also have support for the circle end mills, which are the new generation tools which more and more tool manufacturers are introducing as their new product line. Manufacturers today promise or claim at least 90% reduction in their machining time when using circle end mills. That's primarily because you have a large radius on the side and you end up using big step overs to generate the same scallop that you would generate using a very small step over with a ball nose tool. So that's how the time of machining comes down dramatically. SolidCAM introduced this circle end mills way back in 2019, and we have already almost progressed in every version, and we'll talk about it in our later slides. We support the barrel shape, the lens form, the oval shape, as well as the taper form tools in circle end mills. Next, we have, apart from generic 5-axis, 4 and 5 axis, we have multi-axis machining, which includes multi-axis roughing. So this operation creates a multi-axis roughing toolpath that can be used for either roughing or even finishing of pocket-shaped geometries in full 5-axis. So you can see the examples right on the screen and where you would possibly apply this solution. In the multi-axis finishing toolpath, the user has to specify the floor and the wall, and the toolpaths are created automatically by the software. We also have a possibility to define or decide or give an adaptive roughing feature in full 5-axis. The wall and floor finishing toolpaths, they use the new generation barrel tools, and also they can use ball nose, bull nose, or flattened mill for generating the toolpath. Now, there's something new that we introduced in 2022 is total automation of wall and floor finishing using barrel tools. For example, the part that you see on the screen, the wall and floor finishing has been done automatically just by selecting the surface and not defining anything else. Just select the surface, pick the tool, pick the step over or down step you need, and that's it. Everything else is handled by SolidCAM automatically. It machines all the walls and floors by the step over that you have defined, calculating what is going to be the most optimal tilt angle to allow the barrel shape or the lens shape to be in contact with the floor or wall accordingly. The collision checking, as usual, happens automatically in the background, and you get safe, efficient, and collision-free toolpaths in multi-axis machining. Next, we have a very powerful module for machining impellers and blisks, and we call it multi-blade machining module. This particular module is a very powerful engine. It's used for machining blisks, impellers, and components that are very similar to impellers, including rotors. If you look at the, let's say, the marine industry, there are rotors. The rotors can also be machined using multi-blade machining module. The classic application, of course, is impellers with splitters. Minimum inputs, just define the tool, pick the geometry, define the depth of cut, side step, and you have the tool path. So you don't need to define anything more than that. And more often than like, this particular module is very, very popular with users who have just begun programming in 5-axis. Tool axis control is completely automatic. Root fillets are handled with ease, because the problems in 5-axis is, of course, whenever there are fillets at the bottom. That's where all the complexity arises, but this is handled with ease inside SolidCAM's multi-blade machining. We have separate strategies for doing roughing, we have separate strategies for doing wall finishing, separate strategy for doing the root finishing, as well as the hub finishing. We have port machining, the next one. It's a powerful engine for machining engine ports and tube kind of components. Minimum inputs because it's an application-specific toolpath calculation engine. Automatic tool axis control, no need for the user to define any geometry or supporting geometries. The tool axis is handled directly by SolidCAM automatically. And we have separate strategies for roughing, rest roughing, spiral finishing, and plunge finishing strategies. These all are available in port machining. The output can be, unlike multi-blade, the output here can be in 4 and 5 axis. So you can choose in which axis you need the output, and you'll get the output in that format. Next, we move to rotary machining. Here we have rotary machining that generates 4-axis rotary roughing and finishing tool parts on any solid model. It need not be a screw. It can be any kind of part that rotates around an axis, and rotary machining will handle this particular part. It'll do roughing as well as finishing of that part in 4 axis. We support 3 different types of tools in this: bullnose, ball nose, and end mill. And it works like 3-axis roughing. In fact, we are using the Turbo HSR functionality in this. However, the slicing in Turbo HSR in 3-axis is done in planar space, whereas in rotary roughing, it is done in cylindrical space and not one directional. The user just selects the part and the stock and can rough the entire part in just single operation. Linking, collision checking is automatically done in SolidCAM or rotary. What we introduced in 2022 in rotary is you could now do, instead of just plain 4-axis, you could do 4+1, which means that if you have a floor and the floor is tapered, you can align the tool axis to the floor, or you can make the tool axis normal to the floor, and it can machine the entire part in 4+1 axis. Next is the edge braking, which is a very, very powerful functionality for deburring the entire part after the machining has been performed. There are many edges or non-tangent outer surface topologies. You'll find burr caused by the tool when it's doing the machining, and this burr needs to be removed, because if you don't remove the burr, the part doesn't pass the inspection or QA. SolidCAM edge braking toolpath engine automatically detects these edges and creates a deburring toolpath. And this deburring toolpath can be done in simple 3-axis. It could be done in 3+1. It could be done in 4-axis. It could be done with 5-axis minimum tilting as well as full 5-axis. Currently, if you don't have edge braking, this process can actually take the same amount of time that you took to program the part completely. So it's a very, very manual and a laborious process. And with edge braking, the whole programming time can come down to few seconds. If not minutes, it will be few seconds of programming time with edge braking. What do we have new in 2022? We are supporting, earlier in 2021, we were only supporting ball nose tools. Now we support a host of tools. We support end mills, we support ball nose, we support taper mills, we support taper ball nose, lollipop, and chamfer mills. All of these tools are now supported inside edge braking in 2022. We have edge trimming, and this particular toolpath engine is used for machining the outer periphery of a part, whether it is a composite aerospace part or it's a vacuum form part for automotive. All these parts, after their forming operation is done, they need to be trimmed to get to their exact shape, and edge trimming does exactly that. It's a very powerful engine, and it's a highly automated engine for creating the edge trimming toolpath. The trimming edge is automatically defined, or the user has a possibility to pick the trimming edges himself manually. And the position of the tool is relative to the geometry and can be defined by various options. So you get the output from a simple 3-axis output to the most complex 5-axis output with different tool axis orientation in edge trimming. So if I summarize our entire bouquet of offerings in simultaneous 5-axis, we have got a complete solution to machine any part in 4 and 5-axis. It's really tested. It's been around for the last 15 to 20 years. It's a highly proven 4 and 5-axis engine. It's easy to learn with a very intuitive GUI. It drives the user to pick the geometries, put in the parameters, and calculate the toolpath, including gouge check, collision check, and other things. Users, experienced users will love it because they have got complete control over all aspects of toolpath. The generic, they have got complete control and a complete control over collision avoidance. They can change the tool axis. Once there is a collision, they can automatically change the tool axis to avoid the collisions in the part. And then we have the application-specific simultaneous 5-axis strategies for machining impellers, ports, rotary components, aerostructures, die molds. All of these are really automated functions in simultaneous 5-axis that require minimum user input. So they are very, very popular with people who have relatively very less experience programming 5-axis parts. So we cater to both of them. We cater to the most experienced user, and we also cater to the not so most experienced user in the CAM programming world. Edge deburring and trimming add value to the complete offering. So they complete the entire bouquet of offering that we have for simultaneous 5-axis. Now, in order to simplify this whole concept of 5-axis, we created a new packaging system in SolidCAM. And this is the simultaneous 5-axis packaging, wherein we have got 3 packages. We have got SolidCAM simultaneous 5-axis standard, SolidCAM 5-axis professional, and SolidCAM 5-axis premium. I'll explain to you what each of these bundles have. So with standard, we have got the generic 4 and 5-axis, which is a full-blown 5-axis solution that can machine any kind of part. We have got 3 to 5-axis conversion, which converts 3-axis tool parts of HSM and turbo HSM to 5-axis, multi-axis drilling, 5-axis swarf, 5-axis contour, rotary finishing for 4-axis, geodesic machining, and the Auto 3+2. All of these are added as a part of the 5-axis standard bundle. So if you buy 5-axis standard bundle in SolidCAM, you get all of these. The summary of 5-axis standard, it's an excellent solution for machining any part. I mean, with the generic, you can do any part. There is no limitation on the kind of parts or complexity of part that can be handled by the generic 4 and 5-axis machining. It's a very good solution for advanced users. It has got complete control over the entire process. And this is what is the 5-axis standard. Next, we go to simultaneous 5-axis professional package. It has got everything what standard has to offer, plus it has got multi-axis machining, roughing, as well as finishing using the barrel tools, the automated functions. They're there in multi-axis machining. It has got rotary machining. It has got edge breaking and edge trimming. All of these functions plus the 5-axis standard constitutes 5-axis professional. If I have to summarize what is 5-axis professional, it's a complete power of SolidCAM standard simultaneous 5-axis package with complete control and with a certain degree of automation, because we have got edge breaking and edge trimming, which are automation, rotary machining, also an automated one, multi-axis machining, certain degree of user control as well as automation. So we have got complete control with the generic, and we have got certain degree of automation with the other toolpath strategies that I just talked about. Good for 80% of the customers. It really addresses a large segment of the market. Next, we move to SolidCAM 5-axis Premium, and SolidCAM 5-axis Premium essentially is 5-axis professional, which of course also includes standard, with multi-blade machining and port machining. So it includes both of these very high-end strategies that are there for machining impellers, blisks, and ports and tube parts, along with all that you have just seen in the 5-axis professional package. It's an ultimate solution for simultaneous 5-axis machining. It has got a perfect mix of complete control and great automation. So you have got generic with complete control, and then we have automated strategies like multi-blade port, rotary, multi-axis machining, edge breaking. These are all almost automated solutions for doing 5-axis machining. It's good for all the 100% customers, and it addresses the entire 5-axis segment. We have not left out even a single area of 5-axis that we do not address. We address the entire solution of 5-axis. Apart from selling the 3 standard packages, we also have the hybrid approach in which the user can pick whatever he wants. Let's assume the user wants only edge breaking. So he doesn't have to buy standard, he doesn't have to buy premium or professional, he just buys edge braking and that's it. He adds it to his 3-axis bundle and he's done with it. So that's why we also have the hybrid approach in which we have got all the standard packages and also all the automation packages that we have inside SolidCAM. So of course, the hybrid approach may not be useful for everybody, but I believe the packages that we have created, the standard, professional and premium, are really going to be exciting for all our resellers and customers. And they can pick and choose what they want, or they could go back to the hybrid approach for selecting the 5-axis solution. Right. Thank you very much for watching, and it was really nice interacting with you. Thank you.
Thank you, Amod. 3 questions have come in from the users, from the attendees, I mean. The first question is SolidCAM more flexible or more automated in its approach to simultaneous 5-axis milling?
That's a very good question, Linda. SolidCAM is in a unique position to offer a right mix of flexibility and automation. Experienced users will love the control SolidCAM provides on every aspect of simultaneous 5-axis milling, while the relatively new user will love the automation and power of the application-based Sim5X toolpaths. SolidCAM offers everything both for the most experienced CNC programmer as well as not so experienced CNC programmer.
Thank you, Amod. And now the second question. Since you said SolidCAM also caters to less experienced programmers in simultaneous 5-axis, how does SolidCAM ensure that the toolpaths are safe?
I'll explain that. The collision check in SolidCAM's application-based strategies is totally automated. The user might forget about it, but SolidCAM will not. The collision checking is done automatically by SolidCAM and thus providing collision-free and safe toolpaths. Plus, the integrated machine simulation ensures further visual checking of the toolpaths with a realistic simulation of the entire part, the fixtures, and the machine components. Starting with SolidCAM 2021, we are also having an integration with Simco Edit Professional. Simco provides an extra layer of safety by checking the generated G-codes visually against the part, thus ensuring foolproof, collision-free, and safe toolpaths.
You know, Amod, I'm also learning a lot here. Okay, and now the third question. What are the new things in simultaneous 5-axis that the users can look forward to in SolidCAM 2022?
Sure. There are many features that we have introduced in SolidCAM 2022. Nowadays, barrel cutters are getting more and more popular due to their ability to take bigger step over and thus reduce the cycle time by almost 90%, as claimed by few cutting tool manufacturers. In SolidCAM 2022, we have introduced automated wall and floor finishing using barrel tools, where the user simply selects the wall and floor surfaces and SolidCAM will create optimum toolpaths with automatic tilting to ensure that the barrel form always is in contact with the floor or the wall. Also, we have enhanced the cutter support for our edge braking strategies, which now allow almost any type of tool to be used for edge braking in Sim5X. Apart from this, we have improved our calculation for the rotary machining. Rotary machining is now 3 to 4 times faster than SolidCAM 2021.
Wow. Okay, that's it. Thank you.